everyone, welcome back to the channel and to the series. So in this video lecture we'll go to the next step of the problem solving of the tree algorithms series. So far we have learned about some tree algorithms like depth first search, breadth first search and basic tree terminologies. In this video lecture we'll do some problem solving. So we'll solve a very basic problem of the tree algorithms. We'll see how we can identify the usual strategy, how we basically identify the algorithm to use to solve this problem, the most appropriate algorithm to use to solve this problem. Okay, so we'll be solving this problem, which is subordinates. So let's read the problem statement. Basically, we're given a structure of the company. We have n employees in a company, and we are given a particular structure. We want to find for each employer the number of its subordinate. Okay, so node number one or the employer number one is the general director of the company. So that employer is at the top of the hierarchy. So employer number one is at the top of the hierarchy. There is no direct boss of this employee, right? This is the general director. So let's take an example to learn about it. So we have this example. We have 5 employees in a typical company, and node number 1 is a direct boss of node number 2, node number 1 is a direct boss of node number 3, node number 2 is a direct boss of node number node number 2 is the direct boss of node number 4. Node number 3 is the direct boss of node number 5. So this is how we are given the first test case, and so let's draw the corresponding tree. So we can see that for node number 2, so this is node number 2, this is node number 3, this is node number 4, this is node number 5. So for node number 2, node number 1 is its general boss. So write node number 2 here. For node number 3, node number 1 is its general boss. So write node number 3 here. For node number 4, node number 2 is its direct boss. For node number 5, node number 3 is its direct boss. Like this. Okay, so this is a typical tree. What we want to find is, we want to find the number of subordinates that each node has. Node number 3 has 1 subordinate, node number 2 has 1 subordinate, node number 1 has 4 subordinates, 2, 3, 4 and 5. How are we going to calculate it? And which algorithm to use here? Notice that to calculate the subordinates for node number 1, we must know the subordinates of node number 2. We must know the subordinates of node number 3. Same goes for node number 2 and 3. To calculate the subordinates for node number 2 and 3, we must know the subordinates for node number 4 and node number 5. That's the thing, because that's the observation, right? Because all of the descendants for any particular node are its subordinates. Basically, we just want to find the subtree size or the number of nodes in all of the subtrees of a particular node. So for node number 1, find the number of nodes in the left subtree, find the number of nodes in the right subtree, and that will give me my answer. To do so, we must do the same for all of the nodes. So what I can do is, like, we can see that to find the result for node number 1, I need the result for node number 2. To find the result for node number 2, I need the result for node number 4. So I need to go deep down in the tree, starting from a particular node. That indicates me of using DFS. So I will start my DFS from node number 1. I will move to node number 2. Then I will recursively move to node number 4. So recursively move to node number 4. Move here. At this node, find the number of subordinates for node number 4. It is 0. Now move back to node number 1. Find the subordinates for node number 2. There will be the number of subordinates for node number 4, which is 0, plus 1. 1 counts for 4 itself, the direct child for the node number 2. Okay, so this will give me 1 as the answer for node number 2 when I will be coming back. So DFS 4 is removed, DFS 2 is also removed. Now come back to node DFS 1. Here at DFS 1, the number of nodes, the number of subordinates will be the number of subordinates for the child node for node number 2, which is 1 plus 1. Okay, 1 counts for 2 itself, so it will give me 2. Now from this node 1, recursively call to the right subtree, right child, which is node number 3. So move to node number 3. So here for node number 3, call this function DFS, DFS3, and then again call the same function for DFS5, okay. So for DFS 5, we know that the answer is 0. For node number 5, we have 0, 0 child nodes. Now move back to node number 3, move back to this call, which is node number 3. So move here, and the answer for this will be the subtree size for node number 5, which is 0 plus 1. So this will give me 1 for node number 3. Now move from node number 3 to node number 1. So move from node number 3 to node number 1. The number of subordinates will be the number of subordinates for node number 3 plus 1. So the number of subordinates for 3 are 1 plus 1, which counts for node number 3 itself, the direct child. So 1 plus 1 is 2. We already had a 2 here. 2 plus 1 plus 1 will give me 4. So 4 is the answer for node number 1. And 1 is the answer for node number 2, 1 is the answer for node number 3, 0, 0 is the answer for node number 4 and 5. So that's the strategy to solve this problem. The next problem is how we're going to store the result when I'm coming back from a particular DFS call. Like I am coming back from node number 2 from here to node number 1. What will be the, like I'm coming back to node number 1 from node number 2. How I'm going to store the result for node number 2. Let's see. So we'll use a DP array of size 5 and initialize it with 0. Okay, now when I am moving back from node number 4, since this is the leaf node, we do not find any child for node number 4. I move back to node number 2. I am simply going to increment the answer by 1. So what will be the answer for node number 2? It will be 1 plus dp of node number 4. So what dpi says? Dpi just represents the number of, dpi represents the number of subordinates which node number I has. That's what this dpi represents. So dp4 represents the number of subordinates which 4 has, while this 1 counts for the 4 itself. So 1 plus dp of 4 is 1 plus 0, which is 1. So for node number 2 we have 1. For node number 3 it would, now for node number 1 will have 1 plus dp of 2. What is dp of 2? dp of 2 is the number of subordinates for node number 2. It will be 1. dp of 2 is 1. So 1 plus 1 will give me 2. So 2 for node number 1. Now move to the left child, the right child, which is node number 3. Again move to the last child, the leaf node, which is node number 5. So from node number 5, move back to node number 3, and to calculate the subordinates for node number 3, we will have just 1 plus the subordinates for node number 5. It will be 1 plus 0, that is 1. So for node number 3, we will have 1. Now move back to node number 1. The subordinates will be 1 plus the subordinates for node number 3. It is 1. So 1 plus 1 will give me 2. So it will give me 2 for this one. So 2 plus 2 is going to give me 4. So this will give me 4. So we'll have 4, 1, 1, 0, 0 as the answer array for this given tree, right? So that's what we have to do. You got it? Simple. Just a DFS traversal with the extra space, the array which is used to store the number of nodes in the subtree of a given node. So let's just go and implement the idea. Okay, so this is the number of nodes that we have. We have constructed the given subtree from the given set of nodes, from the given array of nodes. Then I create my visited array. Okay, initialize it to false. I create a dp array of size n plus 1, initialize to 0. Then I call this function DFS starting from node number 1 and pass in the visited array, pass in the tree, and pass in the dp array. So mark this node as true, then iterate over the child nodes. If we find an unvisited child, just recursively call the DFS function for the same child. And after, when we are moving back, like when we are backtracking from the given node, from the given child node, I just have to add the number of subordinates which that child has, which is stored here in this dp array. Okay, and I will increment the answer for the current node by 1, because the direct child, this one, is also counted as the child node. Finally, we'll have our dp array prepared, which I will be printing here. So from node number 1 to the last node, node number I, let's print the subordinates dp of I. Okay, and that's all. That's all I have. That's all we have to do in this problem. So I hope you got the idea how we basically solved this problem using the results of a smaller subproblems. The results of the child nodes are used to calculate the results of the parent nodes. Okay, so you can also say this is a type of DP. Okay, and I hope you enjoyed the video. If you like the video, then hit the like button and make sure to subscribe to the channel, and I will see you